Hello everyone and welcome back to Causality with Boris, broadcast from SobolevSpaces. In this video, I talk in detail about practical aspects of stratification. You will learn about its relation to matching. Matching on a variable and the optimal number of strata are the two main topics in today's lesson. Don't miss the idea that we use matching to achieve comparability of treatment groups, and not to estimate the effect of matching variables. Make sure you watch till the end and compare the takeaways with your notes. And as always, there is an extra material for this video. Click the link in the description and you will see it in your inbox. Stratification refers to placing things into groups. An essential notion of stratification is strata. Stratum is Latin for layer. The word strata means several layers. In health research, the oldest stratification was in occupations. In 1911, the Registrar General of England and Wales placed all occupations into 5 groups: professionals, intermediate occupations, non-manual skilled, manual skilled, partly skilled and unskilled occupations. This simple stratification led to the discovery of a remarkable variation in health status among occupations. But it's not just any arrangement. There are 2 requirements, 2 conditions. First, strata are mutually exclusive. That is, every participant belongs to one strata only. And the second, strata are collectively exhaustive. Each participant belongs to a stratum. It ensures that each pattern of stratification variables appears at least once in data. In a typical study, the combinations of factors define strata. We create multifactorial strata from age groups, socioeconomic status, coexisting conditions, or exposure history. If each of these 4 factors only take 2 values, we have 16 mutually exclusive strata. It's 2 to the power of 4. Stratification is a well-known epidemiological method. We stratify to control the association between treatment and outcome for the effect of other variables. For example, we want to examine a possible association between smoking when pregnant and infant birth weight. Now, birth weight is known to be associated with mother's age. So is smoking. We say age confounds the smoking age association. We need to control for age. So we divide the study population into strata according to the mother's age. Then we turn to the association between smoking history and weight. We compare weight by smoking in strata defined by age separately. Stratification isn't only to control confounding. It helps to detect the effect modification. This graph shows infant birth weight by smoking when pregnant. We can examine the magnitude of differences between smokers and non-smokers according to mother's age. Stratification makes it possible. The idea of stratification finds its roots in matching. What's matching? It's making treatment groups similar or identical in terms of the distribution of other factors. Here's the definition of matching from Elizabeth Stewart's 2010 paper. It's any method that makes distributions of covariates comparable in the treated and control groups. Matching methods have been used since the first half of the 20th century. For example, Greenwood describes it in the 1945 book on experimental sociology. Yet the theoretical basis for matching comes in 1970s. The early rationale applied the following reasoning. Factors that influence the outcome may also influence treatment assignment. And in the absence of randomization, treatment groups may be imbalanced in these factors. In general, we expect a difference in outcomes between treatment groups that differ by other risk factors. Differences between groups would reflect the effects of those determinants. For example, 2 groups with different timing of surgery may show different post-operative mortality if they differ by comorbidity. The effect of comorbidity is mixed here with the effect of timing. Matching forces treated and untreated units to have similar characteristics. After that, we can compare outcomes between treatment groups without the influence of matched factors. From early thinking, matching evolved. It became a statistical technique for estimating treatment effects from observational data. Remember the goal of matching: to pair treated and untreated units with similar attributes for the analysis of association. Is matching a better alternative to regression modeling? Several authors have shown that it is. Linear regressions may increase bias in the estimated treatment effect when the relationship between the covariate and outcome is non-linear, and especially when there are considerable differences between the covariate distributions in the treated and control groups. Matching on a variable is the simplest form of matching. Treated and untreated units are placed into strata according to their matching variable values. If a matching variable is continuous, like age, we divide the range of its values into non-overlapping intervals to define disjoint strata. If a matching variable is categorical, say socioeconomic status, then its categories define strata. We reason that covariation between treatment and outcome variables couldn't be due to a matching variable when it's fixed. Dealing with multiple variables is a challenge due to data availability. If there is more than just a few variables, it isn't easy to find matches with exact values for all covariates. Therefore, matching by every combination evolved to stratification, which lumps observations together for their subject matter meaning. For example, we don't need to match on every combination of age and the number of coexisting conditions. Instead, we may consider just three groups: early ages, and then advanced age with and separately without comorbidity. It's a reasonable three-strata alternative to four groups. After all, our goal is to use matching to ensure comparability between treatment groups, and not to find the effect of matching variables. And there is a theoretical support for this reasoning. Yes, in general it's true that increasing the number of strata will reduce the bias, but the additional reduction in bias decreases as the number of strata goes up. The key concept in determining which covariates to include in matching is comparability between treatment and control groups, at least for the observed covariates. What do we choose for matching? A guiding principle is to include variables known to be related to both treatment assignment and the outcome. And here is the type of variable we shouldn't match on: those affected by the treatment of interest. A common approach is to divide observations into 5 equal size groups. It's done using the quantiles of stratification variable. In statistics, quantile has two meanings: 5 equal groups into which a population can be divided according to the distribution of some variable. Alternatively, quintiles collectively refer to 4 values of this variable. Some also call them cutoff points to avoid mixing up the two meanings. To find cutoffs, we order observations by the value of the matching variable. Then we divide observation into 5 groups. So the first group contains 20% of observations, and they are with the lowest values of the variable. And the last group also contains 20% of observations, but with the highest values. Note that cutoff points for quintiles are not equidistant. Think about what we are dividing into equal groups. It's the study population, not the range of observed variables. Within each quintile, the treated and untreated units have similar values for the matched variable. Therefore, the rationale of stratification seems to be applicable here. We estimate the average treatment effect by summing stratum-specific effects divided by 5. That's the proportion of observations in individual quintile relative to the study population. Here is a conceptual difference with the usual stratification by values of a variable. Cutoff points of quintiles may be different in different study populations. For example, age composition may vary across countries. Some have more younger groups and others have more older groups. Therefore, it's the mean of the individual quintile that gets an interpretation, not the cutoff value. Just one more thing. In 1968, Cochrane made an important observation. Stratifying by the quintiles of a continuous variable eliminates 90% of the bias due to that variable. This result applies to categorical variables too. Here is the main message of this video. Stratification aims to make treatment groups comparable. You learn that stratification comes from the idea of matching treated and untreated units by their observable attributes. You learn that 5 is the optimal number of strata. And don't miss the critical idea for determining which covariates to include in matching. It's comparability between treatment and control groups for given observed covariates. And remember the general rule: only match on variables related to both treatment assignment and the outcome occurrence. We shouldn't match on variables affected by the treatment. Keep on watching.